Synthesis of pentaamine chlorocobalt trichloride. In the fume cupboard, place 30 ml of concentrated aqueous ammonia in a dry 250 ml aluminium flask containing a magnetic stirring bar. Weigh out 5 grams of ammonia chloride and 10 grams of cobaltous chloride hexahydrate and add into the ammonia solution. Cool the slurry in ice and add dropwise 8 ml of 30% hydrogen peroxide. Cautiously add 30 ml of concentrated HCl. On a hot plate, heat the solution at 60 degrees Celsius with stirring for 15 minutes. Add 25 distilled water and cool the solution to room temperature. Filter off the purple crystals under suction and wash with 3 5 ml portions of ice-cold distilled water. Then, with 2 5 ml portions of ice, transfer the product to a watch glass and allow it to sit until dry. Dissolve 0.07 gram of the complex in distilled water in 10 ml volumetric flask and shake vigorously. Record the UV visible spectrum of the aqueous solutions of the synthesis of nitritopentaamine chlorocobalt trichloride. Weigh 2 gram complex prepared in section A and transfer to 250 ml conical flask containing 35 ml water and 2.5 ml concentrated ammonia. Heat and stir the mixture. Cool and filter the solution. Neutralize the solution with 12 molar HCl. Add 2.5 grams sodium nitrite and shake the flask vigorously. Add dropwise 2 ml 6 molar HCl to the solution until precipitate form. Gently stir the precipitate for an hour while cool at 10 degrees Celsius of cold tap water. Separate the crystals using vacuum filtration and wash with 5 ml cold water and 69% ethanol. Record IR and UV-V spectra. Synthesis of nitropentaamine cobalt trichloride. Weigh 2 gram complex prepared in section A and transfer to 250 ml conical flask containing 20 ml water and 2.5 ml concentrated ammonia. Heat and stir the mixture. Filter the solution and add 2 molar HCl until solution slightly acidic. Add 2.5 grams sodium nitrite and heat on water bath until red precipitate disappear. Cool and gently stir carefully at 30 ml HCl. Cool the solution and filter the yellowish brown crystals. Wash the precipitate with 10 ml 6 molar HCl. Record IR and UV-Vis spectra.
nitritoisomer in which ligand oxygen is bonded to the central atom. Nitroisomer in which ligand nitrogen is bonded to the central atom. Nitroisomer is more stable than nitritoisomer, but it will change to nitritoisomer when exposed to ultraviolet radiation. Nitroisomer is found to be more hindered by steric effect. Hence, nitroisomer is more stable than nitritoisomer because it has higher steric effect. Both nitro and nitritoisomers for the cobalt-2 amine complex are different in color. This is because nitrito and nitroisomers have different linkage towards central atom of cobalt-2.
For synthesis of nitritoisomer, dried purple precipitation of pentanamine chlorocobalt-2 chloride was dissolved in the solution that containing distilled water and concentrated ammonia. The mixture was heated and stirred until all solid had dissolved completely, where the milky purple solution changed into dark purple. The solution was filtered after cooled down in order to remove any impurities. 12 molar of hydrochloric acid was added to neutralize the solution and can be easily observed by weighing the indicator paper to follow the pH of the solution. The solution become reddish purple color.
For synthesis of nitroisomer, dried purple precipitation of pentaamine chlorocobalt-3 chloride was dissolved in the solution containing distilled water and concentrated ammonia. The mixture was heated and stirred until all solid had dissolved completely, where the milky purple solution changed to dark purple. Heating the solution will cause error for the next step and will not get exact product. 2 molar of hydrochloric acid was added until the solution was slightly acidic.
Isomers are the molecule with the same chemical formula and often with the same kinds of bond between atoms, but in which the atoms' arrangement are different. Isomerism is a phenomenon where molecules having same molecular formula but different structural formula. Cobalt-2 amine complex is an isomerism linkage coordination compound with ambidentate ligand can coordinate to a central metal atom in more than one way. In this experiment, the ambidentate ligand of interest is the nitride ion. This ion has lone pairs of electrons on the oxygen and nitrogen atoms. Thus, it can coordinate to metals via oxygen or nitrogen.